Today I'm going to solve a perennial mystery that vexes many new Microsoft 365 developers, and that is, where is the Microsoft 365 API? Hi, I'm Bob German, Cloud Developer Advocate for Microsoft, and this is Microsoft 365 Developer Essentials. If you've been developing on some other collaboration product, particularly if it's a single product rather than a suite of products, you're probably used to having a single API to deal with. Well, Microsoft 365 is a suite of products, and it's one that's evolved over a period of time. This picture shows some of the major applications in Microsoft 365. Probably a lot of them are familiar to you. And all of them are secured by a common identity service called Entra ID. If you take an Entra ID directory and all these applications and all the data that a single customer has for these applications, and even the users inside that customer, you have what's called a tenant. That's how Microsoft secures each Microsoft 365 customer's data, is inside this thing called a tenant. If you want to get to the data inside of the tenant, there's one API for doing that, and that's called the Microsoft Graph. The Microsoft Graph is a REST API, by which I mean an API based on the standard HTTP request verbs like get, post, put, and delete, and using JSON as a data representation format. Like the rest of Microsoft 365, the Microsoft Graph is secured using Microsoft Entra ID's implementation of OAuth 2.0. So in order to call the graph, you need to obtain an access token from Entra ID that has permission to make the call that you're interested in. Throughout the next few slides, I'm going to divide things up based on what's running in Microsoft Services Cloud versus what's running in a client application, even if that client application might be something you're hosting in Azure or on a server somewhere. So there are these Microsoft SDKs, and I'll use this term throughout, software developer kits, which are client-side. They're in the address space with your application, and you're going to use those to call those APIs. The easiest way to access Entra ID is to use the Microsoft Authentication Library, and the easiest way to access the graph is using the Microsoft Graph SDK, which handles a lot of exceptions for you, like if the graph needs for you to slow down, it's going to return status code 429 to throttle you. The Graph SDK will automatically retry the request following all of the expected rules. The easiest way to get started is to go to aka.ms/ge to visit the Graph Explorer, which is a web-based tool where you can try the Microsoft Graph calls yourself. Another great tool to know about is the Graph Toolkit, which is a set of web components that will issue all the graph calls for you and that display graph data in the same format that's used inside of Microsoft's own applications. So it's a great accelerator for anything web-based that you might be building, especially if you want to maintain the look and feel of Microsoft 365 itself. So if you're writing an application that stands on its own and need access to the data inside of Microsoft 365, the graph secured by Entra ID is the way to go. But what if you want to actually integrate your application into the Microsoft 365 user interface in various ways? Well, if you've been watching this series, you probably saw my Getting Started videos on Office add-ins, SharePoint and Viva connections, and Microsoft Teams application model. And each of these has a tendency to use different SDKs in order to integrate with the client-side user experience inside of Microsoft 365. So let's take them one by one. We'll start with Office add-ins, which you may recall run in Excel, PowerPoint, Word, Outlook, Visio, OneNote, and your application is running basically in a web browser. It's either an iframe in the case of the web-based versions of these applications, or an embedded browser window in case of the rich client version. In all these cases, your app can use the Office JavaScript API to access the client side of these applications. For instance, maybe you want to edit the text that somebody's working on in a Word document, or update the cells of an Excel spreadsheet. It's interesting that you can create a new email in both the Office JavaScript API library or in the Microsoft Graph. The difference is, if you use the Office JavaScript API, you're actually going to be driving the user interface, and the user will be able to interact with the email. Whereas if you use the Microsoft Graph, you're doing it in the back end and sending it directly on behalf of the user. By the way, a word of warning, this doesn't really work for bulk emails. Now, if you wanted to call the Microsoft Graph from your Office add-in, it's a little bit of an indirect process. Your app, as I said, is running in a browser, but that browser is backed up by some kind of a service, I would assume. So what you have to do is call the Office JavaScript API and call the getAccessToken function, which will give you an access token to call your own service, to call your own application running on the server or in the cloud somewhere. Then on the server side, you use the on behalf of flow to exchange the access token for your application for one that can call the graph. And then on the server side, you use the Graph SDK to call the Microsoft Graph. This is a much more secure method than calling the graph directly from the web browser because it limits what users can do to only things that your server side allows. So now let's take a look at SharePoint, specifically the SharePoint Framework, which allows you to embed your application inside the SharePoint UI. SharePoint Framework will hand you an already logged in reference to the Microsoft Graph SDK, which makes it very easy to call the graph from your SharePoint Framework application, although it does require additional administrative consent to allow this. However, there are also other options in SharePoint. There's a SharePoint REST API, which is a native API that only works in SharePoint. If you're coding for SharePoint on premises, and yes, it still does run on premises, then the graph isn't there. So you might have to use the SharePoint REST API. This allows you to do things like manipulating SharePoint lists and documents. You'll also find that there's a client-side object model, which actually proxies requests to run on the server-side object model. This is typically used for advanced configuration scenarios, like if you want to build a certain SharePoint site structure. It's often facilitated by a community-based SDK called PNP Core, which just makes it a little easier to call the client-side object model. In addition, there's another community project, which is PNP.js, which makes it easier to call the SharePoint REST APIs and the Microsoft Graph from your SharePoint Framework application. Finally, let's take a look at the Teams development model, which I'll remind you works in Microsoft Teams, Outlook, the Microsoft 365 app, and now message extensions also work inside of Microsoft Copilot for Microsoft 365. There are two approaches here. One is when your application is running in a browser frame, meaning it's in a tab or a page, or maybe something called a dialog. In those cases, you're going to use the Teams JavaScript SDK to access the Teams, Outlook, or Microsoft 365 client. For instance, if you wanted to show a dialog box, you would use the dialog function inside of this SDK. Or if you wanted to get an access token, and it works very much like the Office add-in model example, where you'd have to get an access token for your own app, and then on the server side, swap it to get a graph access token, right? That's also handled by the Teams JavaScript SDK. In addition, you'll encounter the Bot Framework SDK, which is where your application is sending messages to and receiving them from these client applications. It might be that you're implementing a chatbot, a message extension where users are interacting with menus and choices, or even adaptive card actions, and those messages all go through the Azure Bot Channel service. And for those, you would use the Bot Framework SDK. Recently, Microsoft has added another option here called the Teams AI library, which you can think of as almost a Copilot SDK. It uses the Bot Framework SDK, which is still supported, to do all the message handling, but it's simpler to use, and it knows about Azure, OpenAI, and other large language model services. So it makes it easy to build custom copilots for your application. There are a couple of other handy software development kits that I want to mention here. One is the Adaptive Card Templating SDK. This is what allows data binding to adaptive cards, which are used inside of message extensions, Teams chatbots, and in Copilot. Also, there's the LiveShare SDK, which allows co-authoring in Teams meeting apps. Underneath of the LiveShare SDK is the Fluid Framework, which you can just get a reference to it from the LiveShare SDK, or if you're not inside of a Teams meeting, you can use the Fluid Framework SDK directly. And in that case, you have to host the Fluid Framework service inside of your own Azure instance. Now that may seem like a lot, but you don't need all of them in any given application. I recommend that you focus on the Microsoft Graph, and depending on if you're building an Office add-in, a SharePoint Framework solution, or a Teams model app, that you focus on the local SDKs that I mentioned for each one of those models. If you like this video, please give it a thumbs up and subscribe to our channel so you won't miss any future videos. Thanks for watching, and I'll see you next time on Microsoft 365 Dev Essentials.